Mr. Beat Stettler. He was the CEO of Onway AG from Switzerland. Thank you. Give him a round of applause. To encourage.
Thank you very much for this applause. You're going to hear a little bit a different approach from my side, because we strongly believe hardware is becoming less and less important. And what you want to have, what you need is software, because the intelligence nowadays is in software and not in hardware. Of course, there is also intelligence but in hardware, but I mean, if you go to a data center, who is going to ask them, what server type do you have? Do you have Dell? Do you have HP? Who cares? You just have a server and you're running intelligent software on it. And that's the approach that we think is necessary to really move this digitalization forward at a much higher speed that we have been seeing so far. Okay, that's us. We come from Switzerland, as said, so we have beautiful mountains. And yes, so if we look what happened in the IT in the last 10 years or 20 years, we have seen some, I would say, disruptions, revolutions, which unfortunately in the transport operator space we often still don't have. And the first one is the separation of hardware and software. I mean, in vehicles we still see that if you buy a system, you have to buy the hardware with that system. In the enterprise space, you would never see that. If you buy a new software, well, you can take a server from Dell or from HP, who cares? So this separation of hardware of software has taken place in other industry, but unfortunately not yet so much in the transport industry. So how does it work today? Well, we have a hypervisor, we have virtual machines, we have containers, which allows you to have different life cycles. So when your software needs an update or an upgrade, well, you install a new VM, you install a new version of your software. If you have a new hardware, a faster hardware, well, you install the new hardware, but it doesn't affect your software because the software even doesn't know which hardware is running underneath. So this independence allows you to run different life cycles of your various infrastructure components that you have in your environment. The second revolution, if you so want, is 20 years ago, every system was, was not communicating. Nowadays, everything is interconnected. And that's needed to make new use cases. All these startups that are in the other hall, they live from data they get from connected devices. They have new innovative use cases, which then they form to do a new or to add another value. So this interconnection is needed in the vehicles as well. And the third revolution, if you so want to, is that a router, a switch, has to be, or was hardware over the last 20, 30 years. But today, it doesn't need to be hardware. It can run as a software in a VM on any device. And this is the basis for all the cloud providers that you have today. If you go to Amazon, you get some VMs, but you also get a router, you get a switch, you get a firewall, you get a VM, a VPN concentrator. All these devices are built in software. So why not doing this also in the vehicle? So when we see our customers' environment, we often still find this silos of applications for different purposes. An application consists hardware, software, antennas for CCTV, another one for ticketing, another one for passenger counting, not talking to each other, not exchanging data, which makes the whole life cycle management of such an architecture very expensive and also very slow, because you always have to go on the vehicle to exchange something instead of just, clicking and having a new software rolled out. And of course, this leads to high cost. But as I said, the worst thing about this architecture is these devices are not communicating. So how can you get all the data that these devices provide to have something new, to have a new use case implemented? So the architecture that we have in all the enterprise companies that you have at home is probably something more like this. You have a switch, you have a network, and you connect every device that you have in your household, you connect to the same network. And of course, you have one uplink, you have one internet access. Nobody would buy another internet access just because he has a new PC. Doesn't make sense, right? So why not doing the same in vehicles? So what do we need? I mean, vehicles are a bit different, so we need a bit different or more advanced features. So what is it? Well, hardware, we definitely still need hardware, of course, but there are many hardware vendors out there who do all the certifications that you need for a bus, for a train, for whatever application that you want. So why not use this hardware and put the right software on it? So what is the right software? In our view, it's software who takes track of mobility, because we are in a mobile environment. We are not at home, so we are, sometimes we have connectivity, sometimes we don't have connectivity, so we have to deal with these things. So we look at the various technologies. We have 3G, 4G, 5G, sometimes we have Wi-Fi, sometimes we even have satellite. So how do we combine all these technologies to create a fat pipe between the vehicle and the ground, so that we can always communicate as performant and as stable as possible. Then we need to aggregate or manage this bandwidth. So once we have this fat pipe, we want to distribute it actively across all the applications. So we want to make sure that the important applications get always priority, and not just from the vehicle to the ground, but also the other way, which shows that a router on a vehicle doesn't really help me, because I cannot prioritize traffic that comes to the vehicle, because the contention is in the mobile network and not on the vehicle. So we need something on the ground that prioritizes the various applications. And then, of course, as already said, we need security. Once we compile all these applications together on one network, we need segmentation. We want to logically separate these applications. We want to have firewall between. We want to have authentication, we want to have encryption. All these features need to be there, but they can be there in software. And once we have this base infrastructure, we can then start putting applications on it. And now this is typically different from customer to customer. Some customers have these applications, some have other. The same as some people at home have these devices and others have others. So one interface, which is typically here, is we call this digital customer interface. The Wi-Fi. Okay, the Wi-Fi can be here to give the passenger internet. That's fine, but do we still need that today? Most people have a flat data package, so they don't need it. But we need it to start to communicate with the passenger, because this is the only way how the vehicle can communicate to the passenger over a local network. If the passenger surfs the internet, he can as well go anywhere else. We don't know where he is. So all the applications, for example, for handicapped, where a handicapped person can, in the vehicle, see what is the next station, when, or to push to get that the vehicle will stop. All these things need a communication between the passenger, so in this case a handicapped person, and the vehicle. And this must be over a local technology, for example, the Wi-Fi. So entertainment in longer distance to save bandwidth, for example. A lot of tourist trains do this, show videos to the tourists that are in the train. Some enhance this with shopping, advertisement to refinance part of the infrastructure. And many of them start using this technology to track passengers. If you have Wi-Fi, and everyone has a device nowadays which has the Wi-Fi turned on, this device is sending signals and we can measure them. So we know how many devices are in a bus or in a train. We can even track when somebody is getting on the vehicle and where, of course, because you have GPS, and where it leaves the vehicle. not knowing that this Mr. So-and-so, this, of course, this is anonymized, but we know there is one passenger doing that trip. And these analyses are very helpful for operators to improve their process, especially in case of accidents and so on. And then on the same device, I want to run my applications. So a router should be a server. A router should be as well a device where I can run my passenger counting on it. Or Echo Drive, there is a vendor here who runs diesel-saving applications on buses, which runs on our router. So any application that comes in the future can be installed without going on the vehicle via the management software on this device, whatever it is. Then, of course, we have interfaces to the vehicle where we can get data over the CAN FMS interface or over other sensors to get information that's relevant for the operator. And of course, we need to know where we are. We want to do geofencing, and all needs to be managed by the cloud. So when you have our software, we are a software house, you can get any of these hardware. This hardware is shipped from China directly to you. You just give them connectivity, and all that happens is it goes to the cloud, it gets the right software, it gets the right configuration, and it's up and running. So you cannot configure these devices by hand anymore, because you don't want to configure these by hand. You don't want to go to the vehicle. You want to do this in your office, over the cloud, over the web browser. And I think that's how it should be in the future. So I give you an example. This is a configuration of a customer who runs Wi-Fi. So on the right side, you have the passenger Wi-Fi. They are, connected to the internet, logically. But there is also this handicapped thing. So the device from the passenger wants to talk to the bus. So how can we do that? Yeah, we need security. Okay, we need a firewall. There is a firewall in the between. And on the left side are all the comfort applications of the bus, like passenger counting, info, and all these things. And it's all in one device. It's a router, but it's not really a router. It's also a server. It's a device who has power enough to run all these things. And this is all software, so you can configure this way. And if you change something, if you have another application, well, you put another software of whatever, proxy or whatever you need to get this different from after the installation on. Load balancing, so you need a fat pipe, as said, just to show you how this works. It needs measurement, because you don't know how mobile networks behave. You lose connectivity. How do you know that? You can only know when you measure. So what we do is all the uplinks, we constantly measure what's the latency, what's the bandwidth, and we combine this to what we say a fat pipe. So for the customer, for the device on the vehicle, they don't want to know which mobile network I have to use now. They just want to use all the bandwidth that's available. And to get this also from the ground to the vehicle, as you can see, we need also devices on land. So in other words, the IT architecture of the vehicle of today should not be only in the vehicle, but also on the ground in your data centers. Right. As I said, these devices should be rolled out without any manual intervention. You get it, you install it, you give them connectivity, and it's up and running, like the consumer devices that we have at home. Here, one example, also from a customer who has even redundancy requirements. So they say, oh, it's nice to have one device only for everything, but what happens if this device fails? So what do we do then? Well, then we build a cluster. So we have two devices running as a logical single device, having one IP address, and for the clients, for the end devices, they don't even realize that in reality there are two hardwares who combine this as a logical cluster. So there you get redundancy. So instead of having 5 routers on the vehicle from 5 different vendors, doing 5 different things, why not having 2 in redundancy? Okay, I think my time is over. The counter is down. So just to quickly go through the devices, as I said, hardware is less relevant, but still we need it. So we have different hardware that we buy from vendors for different purposes. This is a device that you typically use in a ticket machine, in a display on the board of the stop, so you can see when the next tram goes on. Then we have industrial hardware that you can run along the tracks. We have bus routers, train routers, and this is our mobile data center that we use for train. So this is basically the HP server certified for trains, where you can run many applications, many network functions on one device in a train. If you want to know more, we are at stand R12 in the other hall. Please feel free, and we would be happy to see you there. Thank you.
Thank you.